it is second example. So let Sn be the sequence defined by the first term is 1, the second term is 2, the n plus 1th term is Sn plus Sn minus 1, and it is true for all integers n greater equal 3. And question is, find the 8th term of this sequence. So how to find? So we have given S1, S2 and the definition of Sn plus first term. So therefore S3, I have S1 and S2. It is given S1 is 1, S2 is 2, and Sn plus 1 is Sn plus Sn minus 1 for all n greater equal 3. So I have S1, S2. So what can be S3? For n equal to 2, I can find S3 will be S2 plus S1. So it is 2 plus 1 is 3. Sorry, S2 is 1. Sorry, S2 is 1. So it is S2 plus S1 is 1 plus 1 is 2. Then S4, for n equal to 3, it will be S3 plus S2. S3 is 2, so it is 2 plus 1 is 3. Then S5, for n equal to 4, it will give S5, so it is S4 plus S3. S4 plus S3, it is 5. Next term X6, so for n equal to 5, it will give S6. So it is S5 plus S4. So it is 8. Then S7. For n equal to 6, it will give S7. So S6 plus S5. So it is 13. And S8 is, for n equal to 7, it will give S8. So S7 plus S6. So it is 21. And definitely the 8th term of the sequence will be 21. Right. Next example. Write the formula for sequence Sn. The sequence is 1 0 1 0 1 0 and so on. So how can you define the sequence? How can you provide some formula for this sequence? The first term is 1, the second term is 0, the third term is 1, the fourth term is 0. So in the odd places I have real number 1, and in the even places I have the odd numbers, the real number 0. So I can define the nth term to be 1 if n is odd, and the nth term will be 0 if n is even integer for all positive integer n. Right? The next example, 1 3 6 10 15. Can you guess how we can provide some formulae? The first term is 1, the second term is 3, the third term is 6. So what is the relation in this case? Can you guess? So we can define Sn to be n plus Sn minus 1. Try to check whether it is is it true. The next sequence, 1 minus 4 9 minus 16 25 minus 36 and so on. So can you give the formula? The first place it is 1, the second place it is minus of 4, that means square of 2, but the sign is minus. This is square of 3, this is square of 4, but the sign is minus. So definitely n square is there, but the minus sign or plus and minus sign are occurring alternately. So what we can give here? Minus 1 raised to definitely it is not a square. So if I write it is raised to n plus 1, so in the first term it will be square, in the second term it will be minus, right? Yes. So it is true for all positive integers n. The second section of this chapter is limit of a sequence. So the definition of limit of a sequence. Let Sn be a sequence of real numbers then we say that Sn has limit L. The sequence Sn has limit L as n tends to infinity if for every epsilon greater than 0 there exists a positive integer, there exists a positive integer n such that the modulus of Sn minus L is less than epsilon, and it should be true for all n, natural number n greater equal the large n. So we say this as equation star. That means it can be written as limit of Sn as n tends to infinity is L, or Sn tends to L as n tends to infinity, right? So it is similar to the definition of limit, but the sequence Sn has limit L if the difference is less than epsilon for all large numbers n, for all n greater equal the large n. Right. So the note to show that means what we should do to show that the sequence Sn of real numbers has limit L. That means to show the limit of sequence Sn is L, it means we have to show that for every epsilon greater than 0 there must exist a natural number or positive integer n such that the difference is less than epsilon for all n, such that the difference of Sn and L is less than epsilon for all natural number n greater equal the large n. That is, we have to find such positive integer n, such that the equation star, it should hold. The difference should be less than epsilon for all the natural numbers n greater than n, such that the equation star must hold. Right. So let us see some examples. For example, example 1. So consider the sequence. Consider the sequence 1, 1/2, 1/3, 1/4 and so on. So let the sequence is 1/n for all natural numbers or positive integer n. And as we know, the limit of this sequence is 0. So this sequence has limit 0. Right? So how to show this? How to show this? For given epsilon greater than 0, we must find a positive integer n. We must find a positive integer n such that the equation star should hold. That means Sn minus 0 should be less than epsilon for all n greater equal n. It must hold. Right? So now we consider the difference. Greater than 0. Consider this Sn minus 0, which is 1/n minus 0. And what I want? It is 1/n. What I want? We want this quantity to be less than epsilon for all n greater equal n. So we have to find the value of n for which the statement is true, right? So that is 1/n should be less than epsilon for all n greater equal n. That is, it means n should be greater than 1/epsilon from this, and it should be true for all n greater equal n. It means what? This will hold if this will hold. That means this will hold if this will hold. So it will be true for all n greater than 1/epsilon. So what large n I should choose so that it will hold? Right? So thus if we choose the large n to be greater than 1/epsilon, then definitely this difference will be less than epsilon for all n greater equal this capital N. And what is this capital N? It has to be greater than 1/epsilon. And we can say that limit of Sn as n tends to infinity is equal to 0. Right? So we have to choose the value of large n, and which is to be greater than 1/epsilon. So second example, so take it as an homework, that the sequence Sn equal to 1, that means it is a constant sequence for all n positive integers n. So what the limit would be? Has limit 1. So try to show. So for what value of large n the equation star holds? Right. So next example, number 3. The sequence Sn equal to n for all positive integers n does not have a limit. Does not have a limit. So how to show? It does not have a limit. That means there does not exist positive integer n that satisfy the equation star. Right? So to show this, suppose the given sequence Sn equal to n has limit L. So on contrary, we suppose the sequence has limit. What we wish to show? The sequence does not have a limit. So on contrary, suppose the given sequence has limit L. Right? So if the sequence has limit L, so the definition of limit of the sequence or the equation star will be satisfied by this sequence, right? So then for every epsilon greater than 0, there must exist a positive integer n such that the equation star is satisfied. That means Sn minus L is less than epsilon for all n greater equal n. So let us choose for epsilon equal to 1. We can have, so if I choose epsilon to be 1, so we can have Sn minus L to be equal to Sn is n minus L is less than 1, and it is true for all n greater equal n. So what does it mean? So by using the property of modulus, it will be minus 1 less than n minus L less than 1 for all n greater equal. And what does it mean? It means L minus 1 is less than n is less than L plus 1. True for all n greater equal 1. But what this statement says, statement or equation or inequality says. So this inequality shows that, what this inequality shows? So n lies between L minus 1 and L plus 1. So is it true the large n will lie between L minus 1 and L plus 1? Does it true? It shows that the values of n greater than capital N, values of n greater than capital N lies in between L minus 1 to L plus 1. So definitely not, right? So it is impossible. Because then limit would not be a definite or exist. So it is contrary to our assumption. So the given sequence Sn equal to n should not have any limit, right? Does not have any limit as n tends to infinity, right? Next example. Let me give it as a homework to you. Show that the sequence Sn equal to minus 1 raised to n for all positive integer n has no limit. Try to prove yourself. Then the next one is example 5. So find limit of sequence. Sn equal to 2n upon n plus 4 into n raised to half. N varies from 1 to infinity. So the solution. So let us consider the sequence Sn to be 2n upon n plus 4 into n raised to half. Okay, so let me find the value of this nth term, limit of this nth term, limit of Sn as n tends to infinity. So what it can be? 2n upon n plus 4 into n raised to half. So this limit can be evaluated by dividing by n to the numerator and the denominator. So at the numerator I will have 2, and in the denominator I will have it as 1 plus 4 upon n raised to half. And as n tends to infinity, so n raised to half, so definitely it will be 0, tends to 0. So the limit will be 2. So according to the definition of limit of sequence, how to show this? To show limit of Sn as n tends to infinity is 2. It is enough to show that for every epsilon greater than 0, we have to find a positive integer n such that the equation star should hold. Sn minus L is less than epsilon, and it is true for all n greater or equal n. This is equation star. So now consider difference 2n upon n plus 4 times n raised to half minus 2 is less than epsilon. So for what value of n this quantity is to be less than epsilon? So it means what? By simplifying this, it is 2n minus 2n will get cancelled. So it will be minus 8 times n raised to half upon n plus 4 times n raised to half. So the absolute value will be 8 times n raised to half on n plus 4 times n raised to half should be less than epsilon. So try to simplify this as it is. Now since this 8 into n raised to half upon n plus 4 into n raised to half, the quantity will be definitely less than 8 times n raised to half upon n. And then it is equal to 8 upon n raised to half. Right. So as this thing is, therefore 8 upon n raised to half is less than epsilon. It required this quantity to be less than epsilon. So that means what value of n to be chosen? That is, n should be greater than n raised to half should be greater than 8 upon epsilon. So the squaring both sides, n should be greater than 64 upon epsilon square. Therefore, thus if we choose a natural positive integer n or large n to be greater than 64 upon epsilon square, then our equation star must holds. That is, limit of, we can say that limit of Sn as n tends to infinity is 2, right? Then the next